Hello everyone, this is the video tutorial for the parallel series experiment 9 for Physics 201. This is one of my favorite labs because in this lab you actually are going to have a good sense of what we do in a lab, okay, because you're actually going to build circuits, okay, series, parallel, and a combination. All right. So the theory in here is about series. I don't know what happened with the parallel. Doesn't matter. Doesn't matter because I'm gonna go over that in the demonstration. So for series, you are gonna have three resistors. You're gonna have the ammeter, the battery, and you're probably wondering how you do that. How do you do all that? So here are the values of resistors, and this is the value of the battery. So this is what you're gonna have when you click on the link. So basically, you're gonna do what you will do in a lab. Wires, resistors, wire, resistor, wire. Look, it doesn't have to look exactly like I have in the figure there, right? That's a model of how a series should look. But switch there, the battery, and then the ammeter. Now the ammeter has to be connected in series because it has a very small internal resistance. So that's basically, you see what I did? Series. If I close the switch, you have a current. Now I have to adjust this value. So this is supposed to be 25, 50, and 100. So 25, and I'm pretty sure you can, yeah, here. 25, 50. Oh, what was that? 50 and 100. There. My battery has to be in 100 volts. Close the switch. So you have a current. In a series circuit, guys, the current is the same across each resistor. All right? So that's basically your current I1, I2, I3. What you should do is you should grab the voltmeter and measure the voltage on each resistor. Now, you're probably wondering, how do you annotate that? You can do it in Excel. You can put here series circuit. And you don't have to do it in Excel, by the way. You can do it in a Google Doc or in a spreadsheet, in a Google Sheet, right? But basically, I put I total, and that was 0.57 amperes. I1 equals to I2 equals to I3, that's 0.57 amperes. Now you can even put here R1 is equal to 25 ohms, R2 equals to 50 ohms, and R3 equals to 100 ohms. To give you an idea here of how you can arrange this. And then you want to find V1, V2, V3. So you can put it here. V1, V2, V3. So why do I need to do that? Because one of the objectives here is to verify that the addition of all these voltages is 100 volts. So that's basically what I'm doing right now. And that's basically your data. Now, you can solve the circuit theoretically. How? You have series 25, 50, and 100. What you're gonna do theoretically is you're gonna find the equivalent resistance. For series, the equivalent is the addition. So then, how do you find the current on the circuit? I total. That's the voltage provided, which is 100, divided by R equivalent. That should give you exactly, if not very close value to the 0.57 amperes that the simulation gave you. You do percentage error. Now, with the voltages that you found, right? This is R1, R2, R3. With the voltages that you found that you want me to be free in Excel, let's just be one. You measure V1, which is R25. Let's go back to the data. 14.28 volts. And the current that you measured, I1, was 0.57 amperes. So guess what? You can find an experimental value for R. Your R1 experimental is 14.28 divided by 0.57. What is it? Look, right? I get 25.06. Basically, right? So you can do percentage difference. That's what you will do in a lab, in a series. So you can do the same for R2 and R3. All right? So that's series. Let's take a look at the parallel. The parallel is what I feel might be a little bit more tricky. But let's see. Just refresh it so everything goes back to the settings. Look, wire, resistor, wire. Okay, so like that. Then wire, not too far because you need a space for this. Resistor, wire. And then again, wire, resistor, wire. And then you want to have wires here. Like that. And then you could do this, by the way. Yeah, let's just do it like that. Let's keep it easy. So you could have it from any point, but let's just do it like that. Oh, ammeter. You know what? You can cut this. I feel more comfortable if I do this. Let's just put a wire here. There. So 25. Remember which is 25, which, and by the way, you know how you can tell? Because with the current, you're going to be able to tell which is the 25, 50, and 100. Yeah. So what's the battery? The battery doesn't have to be too large in this one because it's in parallel. 20 volts, so that's not a lot. There. So that's your current. That's your overall current. That's the current on the circuit. Now, how do you find the current on each resistor? Right? If you were in a lab, this will be a very interesting part of the lab. In this simulation, you're going to do the same logic. You have to find the current on each of these. So you see how you have the scissors, right? I can cut this in here. And I can introduce the ammeter. When I do that, I'm measuring the current through R1. I can do the same here. So I'm basically placing in series the ammeter for each resistor. Now, let's review the lecture. 25 ohms, 0.80 amperes. 50 ohms, 0.40 amperes. That's exactly what you expect. The more resistance, the less amount of current. Current always looks for the easy path to flow without resistance. So you do the same for the other one. Now, the voltage V1, V2, V3 is the same. So you can arrange a table like we did in the part in here, right? So now will be parallel. So I can just do another one here. Parallel circuit. But now, well, this is the same. Now your voltages are different. So we can put it in here. So yeah, you see one I total, which I have it here, right? 1.40 amperes. And then, okay, V is equal to 6 volts. 6 volts is equal to 20 volts. V1 equals to V2 equals to V3 equals to V equals to 6 volts. Why? That's because of the parallel definition. The voltage is the same. The current splits. So you want to find here I1, I2, I3. And I found I1, right? I1 was 0.80 amperes. And it's 1.4. You want to check that the I1 plus I2 plus I3 is I total. Okay? Now, theoretically, because that's experimental values, how do you solve a parallel circuit theoretically? So a parallel circuit, you have to use the sum of the inverse. So for the parallel, you have 25, 15, and 100. So how do you find the equivalent? or free. So 1 over REQ is equal to 1 over 25 plus 1 over 50 plus 1 over 100. If I do the math, the common denominator is 100. 4 times 25 is 100. 2 times 50, this is 1. So this is 7 over 100 is 1 over REQ. So I flip it. REQ is 100 over 7 ohms, which is about, let's find the value because we're going to use it. It's about 13, but 13.1. Oh, 14, 14.29 ohms. I can find my theoretical total current. My total current. That's theoretical values, right? And you have to show that in the lab. Is the voltage supply was 20. So 20 divided by 14.20. Let's see what we get. Yeah, 1.39, 1.40, which is exactly what you got in the simulation. You're going to do percentage difference, you're going to show this. Now, can you find experimental values of R? Yes. That's why you're measuring I1, I2, I3. So, measure values. What is my measure R1 prime or R1 experimental? Is the voltage, which is 20, divided by I1. What was I1? It's not, well, it's the one that you measure, right? And if you go back to Excel, I1 was 0.8. Well, that's going to be 25, right? That's going to be exactly 25. So 20 divided by 0.8, 25 ohms. So, yeah, there's basically zero margin of error. It's still worth you doing that. So you are going to do the same for R2 experimental and R3 experimental. You want to do the same for those two. Okay? The next arrangement is combining parallel and series. I'm not gonna do it because that's what you guys should do. I have helped you a lot with this tutorial, but I'm showing you, I already showed you how to build a circuit. It has to look like that. So you can measure the current through this hole, right? Make sure that R2 and R3, so this is R2 and this is R3. So this is 50, 125. So 50 and 100 in parallel, you combine it in parallel in series with 25, you find REQ, you can find your theoretical current. Okay, so I want to leave you guys that for you to solve. And I will add a file with just a couple of questions based on this. So the individual questions are going to be quite easy because this lab is a bit longer. And the lab basically is teaching you everything that you need to know for this section. All right. So again, guys, if you have any questions, please send me an email. All right. Make sure you build a proper lab report. All right. By this time, when you're watching this, it's probably going to be around the end of October. All right. Or even the beginning of November. Who knows? End of October. So you should have a good idea what is expected. All right. So have a good day, guys. I'll see you all later.